So let's talk about identifying a place. It's really easy to identify a place when you're talking about a flat surface. It's not as easy when you're talking about a surface that's not flat. So if it's a flat surface, you would talk about when two lines intersect, but that's not going to work on Earth. So what we're going to have is a set of unique types of lines that are going to be the intersection of parallels and meridians with respect to the rotation axes. The parallels are going to be our latitude lines, and the meridians are going to be our longitudinal lines. So the latitudinal lines work as far as this is concerned. We have the equator, which is 0. Then you'll have the parallels, 20, 40, 60, 80, all the way up to 90. These are usually called north. And then you'd also have 20 degrees south, 40 degrees south, which tells you whether you're south or north of the equator. From a person's perspective, though, the latitudes or the parallels are going to be kind of up in the sky at an angle. So thinking like above the horizon is the best way, or directly above you. The longitudinal lines, on the other hand, are going to be kind of like slicing a cake. There's going to be 0, 20, 40, 60. They're east and west. And then they're also going to have 0 up to 180 as being specific lines. The 0 is going to be the prime meridian, which is going to be important when we start talking about time zones. But these are kind of like putting the line on the ground around you. So taking a slice of cake out of the earth. Along with those latitudes and longitudes, we have what's called these specific locations: the Arctic Circle, which is in the north, the Tropic of Cancer, the equator, the Tropic of Capricorn, and the Antarctic Circle. So you need to know those lines as well. Those are the major lines. Now, Marshall, Texas, we are located at 32 degrees north latitude, so that's above the equator, and 94 degrees west longitude, which is west of the prime meridian. Daily time, how we tell our daily time is a lot to do with our Earth-Sun motion. Viewed from above the North Pole, the Earth revolves in a counterclockwise position about the Sun and also rotates in the same direction. Remember, Venus is the only one that rotates and orbits in different directions. So on Earth, the Sun will always rise in the east and always set in the west. It will never be the opposite. On Venus, the Earth rises in the west and sets in the east. And that's how we mark our days. Now, another thing that's important to us is noon. Noon is the time at which the sun is at the celestial median, that pink line. Now, as we go through summer, noon, the sun, if you track the sun every day at noon for the whole year, you would see that the sun is going to hit at a higher spot each day. So each time it hits noon, it's going to be, in January, it'll be close to the horizon. As we get to July, it's going to be further up in the horizon. And then as you work back towards December, it's going to fall back down each day at noon. Now, apparent local solar time is given by the position of the sun in the sky. So this is not using like a watch, 2 o'clock, 3 o'clock, but using the apparent position of the sun. Normally this is measured with sundials. So here's an example here. We don't use our sundials like this anymore, but you can see it casts the shadow, which would tell you the approximate time. And this is not the same as the time shown on clocks. So our digital clocks that we have on our phones and smartwatches are thanks to satellites. So it's a little bit different than the sundial. Now what this brings us to is standard time zones. The Earth is round, so we're going to have 360 degrees of longitude, and they are going to be divided into 24 separate zones, with each zone being about 15 degrees, and that's math. If you take 360 divided by 24, you get about 15 degrees. However, these time zones are adjusted for local consistency. So if the line falls in between a town, the town is not going to be divided. It's not concrete. The town can pick to be in one time zone or the other. So if we look here, this is going to be, see if I find it over here. This is the prime meridian, which goes through Greenwich. And then we have this other side over here, which is the 180, the international date line. So that's the other important line. Now here in the United States, we have Pacific time, which is on the Pacific coast, Mountain time, which is through the mountainous regions, Central, which is probably the largest, and you can see it's almost all of Texas, Oklahoma, Kansas, all the way over to Tennessee Valley and Alabama. And then on the eastern coast, we have the Eastern time zone. So you can see that sometimes the lines are on the state and sometimes they divide through the state. But when you're in places like North Dakota and South Dakota, sometimes the cities will choose to pick the time zone of a place close to them rather than the one that they're exactly located in. So during daylight savings time, clocks are set ahead, so we spring forward in March and we fall back in November. What this means is during the summer we get extra sunlight during those summer evenings, which has a historical significance for agriculture because they needed that extra hour to do work. So we don't really use it for that purpose anymore, but it is kind of nice when it's darker later, you can sleep in better, or when you have more evening time at home when you get home from work. Now the international date line, like I said, is the 180 degrees meridian, and it's designated to correlate days with 24-hour time zones, which we just talked about the ones for the United States. So we talked about 4 of them, and there's going to be 20 other time zones across the world. So phases of the moon are going to be the next thing we'll talk about. The phases of the moon result from the fact that we're going to change positions of the Earth, Sun, and Moon, meaning whether the Sun, Moon, Earth is like this, or if the Moon's on the other side, or Moon is next to, they're perpendicular. And it gives us unique shapes, right? Because we're going to be able to see, example, if the Moon is between the Sun and the Earth, we're not going to see the full bright moon. It's going to be a new moon because we'll see the dark side. First quarter is where you can only see a quarter of it. The full moon is where you see the entire moon illuminated. And then the last quarter is where we would only visualize a quarter. Now, one interesting thing is the same side of the moon is always pointed towards the Earth. So we've never seen the quote-unquote dark side of the moon. Even when we're looking at a new moon, it's not the back side of the moon. We always see the same side. So the dark side of the moon, we don't see from Earth. So now we're going to talk about eclipses. Eclipses are a really wonderful phenomenon that happens. Back in the day, there was a lot of mystique centered around them because it would make the day completely dark. Very ominous, associated with like doom and gloom and end of the world stuff. But we know now that the eclipses are really just kind of an intricate dance between the sun, the moon, and the earth. So solar eclipses are where we're going to have the following, where the sun and the moon and the earth are going to be in this particular order, and the sun and the moon are going to be so perfectly arranged that the moon falls into the umbra, blocks out all of the sunlight, and the umbra, the dark part, falls on Earth. So essentially, something that's as small as a mustard seed, blocks out all of the sun from something much bigger, and all we see is darkness. When that happens, you can usually see, it'll be like the moon here, the darkness, and then we'll see the bright glow of the moon around it, which is the only time it's safe to look at the sun. Otherwise, it will burn your eyes. But when we have a solar eclipse, there's a brief minute, I think it's usually less than 2 or 3 minutes, where you can look directly at the solar eclipse and see it. It's rare to see one in your location because, one, the weather, but 2, they don't always pass over everybody in the earth. So we had one about 2 or 3 years ago pass through East Texas, and we were able to see a partial eclipse. We did not have a full eclipse here, but it was pretty close and pretty impressive to see. The lunar eclipse, on the other hand, is where the moon is going to be engulfed by the Earth's umbra. And so the way that this works is it's the sun, and then we have the Earth, and then there's the moon. And the Earth and the sun have to be perfectly lined up to where all of the sunlight is blocked by the Earth, and the only thing that is hitting the moon is shadow, which is kind of what umbra is a shadow. So more likely to see a lunar eclipse. The reason being is that the moon and the sun are much different in size. While the moon and the earth are closer in size than the sun is to either of those two, the sheer odds that something so tiny will block out all the light of something so much bigger than itself is limited. So we tend to have more lunar eclipses in one lifetime in one area than we would a solar eclipse. But they're both pretty unique phenomenon that are pretty amazing to see. And if you've never seen one, I would encourage you to find out if there's one ever nearby you and take advantage of going to participate. This is the end of chapter 14. So make sure that you've taken all your notes and you've completed it and that you submit them when